Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Anandi, Pune. Today's session based on demonstration of machine translation application using encoder decoder architecture. In this notebook, I am going to explain how to implement machine translation application using encoder decoder. This in machine translation application, we are translating one language to another language. Suppose you are giving the input in English language and you can convert into other any Indian local original language. This neural machine translation example uses the teacher forcing method without attention mechanism, and in encoder decoder we are using LSTM architecture to accept the input to encode the input, and whatever output generated by encoder will be the passed as input to the decoder. Now let us discuss. Already in previous recording, already I have explained about the basic architecture of encoder decoder, and also I have explained the same case study, that is the machine translation. Now here in this notebook I am explaining the code in brief. Now these are the libraries we require for the implementation. Now in this library, we are using the LSTM embedding layer, dense layer, and bidirectional layer. In encoder, we are using the bidirectional LSTM. So here we need to add import bidirectional file module. Now here in this example, we are using dataset for machine translation. Now here you can see, now here in this example I am converting English language to Marathi language. Now here this is the dataset. Dataset is in the form of txt file. Now in this txt file contain 3 columns. First English, then Marathi keywords, and then these are the information about the dataset and this language. This is considered as a noise in a input dataset. Once the dataset is uploaded on your Google Drive. Now here I am uploaded this data set on my Google Drive, and from Google Drive I am using this data set for the implementation purpose. Now here in the data set there are 3 columns: English, Marathi, and noise. There are total 46,995 and 3 columns are there in selected data set. Now, whenever we are passing any text data for any deep learning and machine learning algorithm, before we need to pre-process the data set. Now here we need to call the functions, NLP function, to pre-process the data set. Now first converting a data set into lowercase by applying the lowercase function. Also then we are removing the quotes, and then set the remove the all special character from the data set, remove the all numbers from the text, and also we are removing the extra spaces from the given data set. Now whatever the data set, there are 3 columns in our 2 columns, English and Marathi language in our data set. Now here for target language, now here in this example the source language is English and target language is Marathi. So here we need to add start and end tokens in target sentences. Then for Marathi language we need to add start and end token. Now after pre-processing, data will be look like this. Now this is the English language. Now here I learned a lot from. Now start, मी तुझ्याकडून भरपूर काही शिकलो. Now this is the Marathi sentence. Now here in Marathi sentence we are adding start and end token. Okay, same for the other lines. Now here once the data start and end token added, then we need to work on the unique words in a given data set in source as well as target language. Now this code to create the vocabulary of unique word in both language. Now here also you have to calculate the maximum length of source sequence and target sequence. Now sentence is considered as a one sequence. Okay, now here the for length of source sequence is for English language is the 34, whereas the source of target sequence is 37. Then we need to display the unique number of tokens in English, that is in source language as well as target segments. There are 5,839 English tokens, whereas the 14,393 tokens in Marathi language. Now here we are adding the padding in for target language by adding 0, and so the length of the sequence will be +1, that is 14,394. Now here next word, to add the set the unique index to every words in a both data set in for both sequence English and language. Now here the unique number will be assigned to both all tokens in a both language. Now shuffle the data. After shuffling the data, it will be look like this. Now here we are preparing the data set for the training and testing purpose. Splitted the data set. 90% of data will be used for the training, and remaining 10% of data set used for the testing. You can also increase and decrease this value. And next, once the data set is ready, then after pre-processing you can create the pickle file, because pre-processing require more time. So here, instead of training a same data set every time, you can save this .pickle file in your drive for next algorithm. Okay, now we are creating, through this code we are creating the batches for the training purpose. Now once the data training batches are generated, then we are calling the encoder decoder architecture. Now already in previous recording we have discussed how encoder and decoder will work. Now here in this example, this is the English language converted into another language. Okay, now already we have discussed the input is given through the LSTM. LSTM will work in both encoder and decoder. Then encoder encode the contextual information and stored into contextual information, that is hidden state and cell state, and then it is called as a contextual vector, and this it will be the input to the decoder. In decoder, this is the ground truth sequence for the given input sequence, and here we are using the teacher forcing method, whereas the after start immediately, the here in ground truth sequence, here we are the decoder will force that after start next word will be the first word in a given ground truth sequence, and then whatever output will be there, that will be the input for the next step. Now here we are defining one parameter that is called as a latent dimension. Now latent dimension in the encoder decoder architecture, latent dimension of the encoding space refers to the dimensionality in intermediate representation. That is, whenever we are passing the output to the encoder, then we need to define the dimension of that latent space or contextual information. Here latent dimension is equal to 40. Next, we are building the model for the training purpose. Now here, this is the code for encoder. Okay, now in encoder we need to define the shape of the input. Then once the input is defined, then we are passing this input, whatever text is there in the form of English target source language sequence, that need to pass as the input. Now number of encoder token. Now we need to pass the number of encoder token, then latent dimension, mask 0 is equal to true. That is, we are adding the padding, and then encoder input will be the input for the embedding layer. Then we are passing the input through the embedding layer, and this LSTM we are calling, this is the LSTM. In LSTM, latent dimension, that is equal to 40. That is, expected size of output of the encoded input is 40, and return state is equal to true. Means after every LSTM, the return state output of the H and T C will be passed through the next time step. Now here we are calling this encoder function for the given input. Okay, the input is passed through the embedding layer, that value will be passed here, and here this encoder LSTM will return 3 value: encoder output, encoder hidden state, and cell state value. In encoder, we are discarding the output, and only we are focusing on 2 value. Only we are keeping these 2 value, hidden state value and cell state value. Once the encoder is defined, this encoder model defined, then we are moving towards the decoder. In decoder, the output generated by encoder will be the input. Now here in encoding, in decoder, we are defining this embedding layer, and in embedding layer we are giving the number of decoder tokens. Okay, that is the Marathi tokens, number of Marathi tokens. Then latent dimension is equal to 50 and mask size 0 is equal to true. Now here we are calling function LSTM, which will return three value: output, hidden state and cell state. But in decoder we are not using last hidden state and cell state value, only we are focusing on output, and whatever the output is there, that will be the input for the next step. Then we are adding the dense layer, and here we are using the softmax function to calculate the probability of the word occurred at each time step in output. Okay, then once the decoder model is defined, both model will be put in one. We are creating the model using this both model, encoder and decoder, and this will be the summary of model. Okay, now once the encoder decoder model is ready, then we need to compile our model. Now in the compiling our model, we are using Adam optimizer, categorical cross entropy for evaluating the performance with respect to the loss, and metric is equal to accuracy. And then we are training and testing our model. Now for practice purpose, just I have trained this model for 1 epoch. You can also increase and decrease. Once the model is trained for 20 epoch, you can save the weight of model, because for training this model with this data set, it will require more time. So here you can save the weight. Then you can also display the graph for validation loss and training accuracy loss. And then here in training we are using teacher forcing method, but in testing or inference we cannot use the teacher forcing method. Now this is the code for the inference testing purpose, and here we can see result of inference or testing phase. That is, suppose here the sentence is given prediction result, testing prediction result. This is the unseen data set. Okay, they want to meet you, that is actual ground truth is that त्यांना तुम्हाला भेटायचं आहे, but it is generated output त्यांना तुला भेटायचं आहे. Now here one more sentence, I make my own rule, मी स्वतःचे नियम बनवतो, but output is displayed मी माझा जन्म आलो आहे. That is a somewhat wrong. Okay, now again it depends upon the how many times you are training your program, how type of optimizer you are using, and how many number of hidden layers you are using, what is the dimension of the latent space. Now based on this, the different parameters, the performance of algorithm can be displayed. Okay, this is all about the machine translation example using encoder decoder. Thank you.